I'm going to provide some feedback and guidance with regard to passing the writing sample test. So the agenda is I'm going to cover claim drafting, problem and solution section, drawings, the description, and then common issues that I see in writing sample tests. So let's start with claim drafting. So one of the important things is to make sure that you are paying attention to the instructions. The instructions for the writing sample test at our firm specifically indicate that you are to prepare a method claim of moderate scope, and a single one at that. And so make sure you're listening to and paying attention to what we're asking you to do and follow it. I've seen many times where a candidate might write 20 claims or will write an independent with several dependents. Maybe write a system claim or a device claim versus a method claim. And then the moderate scope part of it. So, it's important to make sure that your claim isn't too broad and isn't too narrow. So too broad being that it's a bare bones claim. It's covering the minimum things that need to be covered to cover, let's say, image search, for example. We're going to use that same example throughout this, image search. And then too narrow being that there's not a lot of extra steps that aren't required for novelty. So make sure you're paying attention also to what we're saying in the instructions as being the novel aspects of it. With regard to the image search, we specifically say it's text in and image out. So it's important to say that the query that's being received is text and not an image, for example. It's not that we're trying to match other images to a sample image. We're trying to match text to images. And then images out is the other part of it. And so it's not that we're going to provide links to images. We're not going to provide descriptions of images. We're going to provide images. So it's important to make sure that you're paying attention to the instructions. Let's move on to technical accuracy. It's very important to understand how image search works before you write a claim to image search. You wouldn't believe how many times that we get writing sample tests where the candidate has drafted a claim that is technically inaccurate. So make sure you understand how it works before you start trying to claim it. Let's move on to the next thing. Make sure to cover the important aspects and elaborate on the novel steps. So I talked about the important aspects when I was talking about paying attention to the instructions. Text in and image out. That's what we said is the novelty. So make sure you're covering those. But are those the most novel parts of the claim? Probably not. The most novel part is how do you match text to an image? That's the thing that makes image search work. And so that's the part that you should spend a little bit of time making sure to flush out in the claims. So let's move on to the next thing, and that's including hardware in the claims. So as you know, if you have a claim that doesn't have any hardware in it, there's a likelihood that a patent examiner may say that the claim might be implemented in somebody's head or on with a piece of paper and a pen. And we want to make sure that we are at least moving away from that by including hardware in the claim. So we have to think about, well, what hardware are we including? And so the hardware should be directed to the main actor of the invention. And here the main actor is a search engine, an image search engine. And it's important to make sure that it's understood that the actor is hardware. So we could claim an image search engine, but an image search engine really is software, not hardware. But it's implemented on a server. So it would be better to claim maybe by a server device or by one or more server devices. There's a collection of them operating together. So make sure you're including hardware and include the hardware in the body of the claim, not just the preamble, to make sure that it's tied to the steps of the claim. So let's move to the next one. That's claim steps limited to activities of a single actor. So from an infringement standpoint, it's easier to prove infringement if all of the claims are from, or all the claim steps are from the standpoint of a single actor and not multiple actors. So in this situation, we're talking about the image search engine. So all of the claims should be from the perspective of the image search engine, not from the perspective of a user or from a user device, or a combination of a user device and or an image search engine. So instead of, like, for a first claim saying we're going to transmit a query to a server device, it should be from the server device's perspective. So we should be receiving a search query from a server device. And then what goes without saying is there shouldn't be any 112 issues. We're talking about one claim of moderate scope. Make sure you pore over it to make sure there's no antecedent basis issues or any other issues like typos and those kind of things. That steps kind of flow together. There's no step that's kind of hanging out there by itself that's not tied to anything else in the claim, and those kind of things. So let's talk about the problem and solution section. So the problem is a description of what existed before the invention. And so what existed before image search existed was there was web searching. And so if a user wanted to find a particular image, the user would have to perform a general web search and be provided with a list of websites or web pages. And the user would then click on links and visit web pages looking for the image that the user desired. That was the problem. So what's the solution? The solution is that we have image search, so you can tell us what you're looking for, and we're going to provide you the images without you having to go to all these websites. Now, the key part of this is not just to describe human problems and human solutions, but to describe technical problems and technical solutions. That's kind of what the so what statements are. Like, so why do I care that there's this problem, and why do I care about the solution? And so we need to describe, what it is in technical terms, like what the technical problem and the technical solution. Now, the technical solution should be solving the technical problem and almost be phrased in the opposite of what you describe the technical problem is. So what's the technical problem with image search? So with the prior art, if a user wanted to find a particular image, the user would enter a query into the user device, send it off to a search engine. The search engine would return a list of web pages. And the user would then have to click from one web page to the next, to the next, to the next, searching for a web page that had the image that the user desired. So what's the technical problem with that? Well, the technical problem with that is that it's slow. So, and why do we care that it's slow? Well, it's slow, and because of the slowness, we're using computing and communication resources, right? So if it takes a long time, that means that the user might have to perform multiple searches. That means that the user might have to click on many more links than the user would otherwise have to with an image search. And all of those use computing resources on the user device, computing resources on the search engine server device, and communication resources because those communications go over the internet, and they're using resources in the internet. And we could really alleviate all of those technical problems by just doing an image search with our. So now let's turn to the drawings. So the important thing really with all of this is to follow the instructions. So the instructions here say, create 1 to 2 drawings. So you should have 1 to 2 drawings. The instructions also say, don't provide us a flow chart or an environment figure. And an environment figure, for example, with image search might be a user device connected to the internet or some network connected to a server device or a search engine or something like that. And that's an environment figure. And what we said instead was to provide an overview figure. And the key thing is, with regard to an overview figure, is that you should be able to look at it and determine, at least have a good guess at what the invention is here, image search. Moving to the next thing, show the main actor in the drawings. So, it's one thing to have have two drawings, one before where you're entering the search query and one and after where you have the search results showing some images. And that's fine, and someone might be able to guess at what the invention is. But what's much, much, much better is to show the image search engine in the drawings. That's the main actor here. It's not the user interface isn't the main actor. It's not the user device that's the main actor. It's a search engine. And we should really be showing the search engine in the drawings. So let me move to the next thing, the labels and the reference numbers. So the labels should be intuitive, meaning that someone should be able to read them and understand what you're getting at with respect to the labels. And the reference numbers should be logical and predictable. So what do I mean by logical and predictable reference numbers? I mean reference numbers that follow a pattern. So 102, 104, 106, 108, 110, 105, 110, 115, 120. Okay, those are logical and predictable. If you put 101, 102, 106, 110, 123, and 128, those are not logical and predictable. And the reason that they're not logical and predictable is no one's going to know what the next number is, and or whether they missed a number somewhere in between. So, using logical and predictable reference numbers is important. It's also important because you're the one assigning the reference numbers. Assign them in the order that you're going to cover them, because it's logical and predictable to cover reference numbers that go in a logical and predictable manner, that follow the pattern. So 102 is covered before 104, which is covered before 106, which is covered before 108. And it's not that you're just kind of all over the place. Hey, 102 is covered, then we go to 110, then we go to 115, and then we're back to 104, and then we're back to 106, and then we're at 120. That's not logical and predictable. So assign them in an order in which you're going to cover them. And then the last thing here is the real test. And I kind of mentioned this above, but I'm going to say it again. The real test is that you should be able to hand this one or two drawings to somebody who has no idea what the invention is, and they should be able to make an educated guess that the invention is image search. If they have no idea what the invention is, then that says that your drawings aren't any good. Your drawings should tell a story, and the description should supplement the story. So think about looking at the drawings in a vacuum and determining whether you could understand yourself what the invention is, I guess, from looking at the drawings. So now let's go to the description. So the description should be logical and predictable writing. So what do I mean by logical and predictable? That it tells a story, it flows in a direction that there aren't surprises. So when someone gets to an end of a paragraph, they should have a guess at what's coming next. If they have no idea what's coming next, that's problematic, because that means it's not logical or predictable. Or what comes next is a surprise to them. That's also not logical and predictable, and both of those are problematic. So moving to the next thing, I kind of mentioned already about telling the story. The description should tell a story from the beginning to the end and not jump all over the place. So it should be, the beginning of the story, then the middle of the story, and then the end of the story. The beginning is stuff about a query, I would guess, and the end of the story would be something about providing images and what a user might do once they got those images. And the middle of the story is how do we get from the beginning to the end. The next thing here is technical accuracy. So it's really important to understand what you're writing about. That's what this whole field is about. Like, we have to come up to speed, understand what the invention is, and then write it with technical accuracy. So if you do not understand, for example, how image search works, you should not guess at how image search works. And I find that there's a lot of candidates who take the writing sample test who have no idea how image search works. And I think they believe they know how it works. And so they just go with their gut instead of looking it up to see if they're accurate or not. There are many, many writing sample tests that we have received where someone would write that we receive a query, and based on the query, the image search engine goes out on the internet looking at web pages, trying to find a web page with an image that matches the query. Now, we've all used image search before, and image search returns millions upon millions upon millions of search results in a fraction of a second. There's no way that a search engine could be going out onto the internet looking for images and be able to return millions upon millions upon millions of search results in a fraction of a second. That's common sense. So thinking about what you're writing, thinking about making sure that it's technically accurate, and if you don't know how it works, look it up. And then the last thing here is use common words. So if the reader has to look up a word to understand what you mean, or look up a word to verify that you're using it accurately, both of those are problematic. You should be writing to a layman, to someone who has a basic vocabulary, and not use fancy words to show that you know fancy words. You should use common words and words that everybody understands. And that way, when someone's reading it, they're not going to have to stop to figure out what you're trying to say and or go and look up what the word means and or verify that the word is being used correctly. So I'm going to wrap up with just common issues, and I'm going to reiterate some of the things that I have already said with regard to the claims, the drawings, and the description. So the claims, again, follow instructions, make sure that the claims are being drafted from the standpoint of a single actor, make sure that the claim is of moderate scope, not too broad, not too narrow. Make sure that you are embellishing on the important parts, the novel aspects of the claim. And make sure, again, that it's technically accurate, if I didn't say that. With regard to the drawings, again, the drawings should tell a story. Someone should be able to look at the drawings in a vacuum and understand, or at least have a good educated guess on what the invention is. If your drawings do not tell that kind of story, then you need to redo the drawings to make them tell a story. And then finally, the description, logical and predictable telling of a story. Those are the key things, in addition to making sure that it's technically accurate. Okay, that is the end of my presentation.